Is the microbiome important to human health? This is a fundamental question in our field, right? So for about 10 years now, we've just understood that this thing exists, this thing called the microbiome, and we've been exploring it. It's sort of like Darwin and the Beagle, going around, seeing what's there, characterizing who's there, what are they doing. And we're just beginning to hit the point in our research where we're beginning to understand exactly how the structure of the ecology of the microbiome actually influences human health. There's been a lot of hype around the microbiome. What we see week after week, every week there's a new paper in Nature showing this kind of amazing new insight into how our microbes actually influence our health. So even if 1 or 10% of the associations between health and disease turn out to be causal or real with the microbiome in the human body, that's going to revolutionize medicine as we know it. It may not come as a surprise that we take a systems approach to studying the human microbiome. A lot of the work that's been done in the microbiome space has been actually just asking, here's the ecology of someone's gut who's healthy, here's the ecology of someone's gut who's sick. What are the differences? What species are more abundant here or less abundant there? And we've racked up this huge number of associations between certain organisms and certain diseases. So we know who's more abundant, who's less abundant, and under what conditions. What we don't know is how do we map that information into functional space. Just because the ecology is different, does that actually mean there's any sort of difference in the physiology or health state of the host organism? The approach we take is multi-omic, right? And this is where metabolomics comes in, where we can sequence the microbiome, we can know who's there, but in order to understand the functionality of what's happening when the ecology changes, we need to have the actual functional outputs. And the functional outputs of the microbiota are the small molecules that it produces. And so by synthesizing and integrating these multi-omic data, we're able to build up a more mechanistic understanding of how a change in the ecology of the system precipitates some sort of change in the body. So as some examples, recently this past summer, we published a paper using Metabolon's data to show that you could actually infer something about the structure of someone's microbiome by looking in their bloodstream. A small number of metabolites circulating in their blood can tell us something about the ecology of someone's gut. This betrays this really intimate connection between microbial ecology and what's happening in our body. All these molecules that are bathing all of our organs, many of them are coming from our microbes. Our group is looking at ways in which you can use time lags between omics sampling, so when the blood was sampled and when the stool was sampled, and build a model that allows you to put arrows on associations. So before we were just looking at correlation between the metabolomics and the microbiome. Now we're trying to build causal maps that tell us, this metabolite drives up the abundance of this bug in a person's gut a few days later, or vice versa. This bug seems to be causally influencing the abundance of a particular metabolite. That's going to allow us to build a map, a causal map that allows us to, engineer the system. You put in one input, how do you get a particular output? And I guess for now, that's how we're trying to drive forward the field. The future of the microbiome space is going from ecology to mechanism, understanding actually how is the microbiome impacting host health. You have to understand enough about the underlying system, the mechanistic model of the system, in order to make predictions, to engineer it. Right? The microbiome is this really complicated thing where it's like a game of pickup sticks. You pull on one thing, pull on one thread, and the entire rest of the system has ripple effects and shifts and changes. So it's really hard to manipulate. It's really hard to change because it adapts around what you're doing. So we built the groundwork over the past decade. And now what we need to do is take that groundwork and go towards synthesizing all that complexity, building a mechanistic model, and making real predictions. And in order to test those predictions, and in order to make sure those predictions are truth, metabolomics is going to play an enormous role, right? That is the ultimate functional output of our microbiome, is what metabolites, what small molecules they're producing. There's a conversation happening between our microbiota and our bodies, and that conversation is in these small molecules. So understanding, listening into that conversation is going to allow us to begin to build a map for how ecology affects health, which ultimately will allow us to engineer the microbiome to optimize and improve human health and wellness.